How'd you do on the homework, Jeremiah?
Pretty good.
Pretty good, right? You like pre-calc so far? Okay. Let's see if you still like it after this lesson. Okay. Okay. So we're talking about trig identities. So I know we talked about there's sine of negative theta is the same thing as sine of what?
Wait, the sine of theta.
Sine of negative theta is the same as negative sine of theta, right? Cosine of negative theta.
Negative cosine theta.
No, just cosine theta. Remember, the negative doesn't impact it,
Oh, okay.
but tangent does. Okay. And you also know like sine theta. Same thing as cosine 90 minus theta, right? Your your cofunctions. Secant is the same thing as cosine of cosecant. Oh, sorry, not cosine, cosecant. And then tangent, same thing as cotangent 90 minus theta, right? You remember those from last week, right? Okay. You should also know you should know pretty simple ones, and you should also know sine theta cosecant theta equals 1, right? And then cosine theta secant theta equals 1, and then tangent theta cotangent theta equals 1, right? Those are pretty easy. Okay, we're going to use these though to get to some more complicated ones. Here's where it gets exciting. Okay. So you start with the Pythagorean theorem. Let's say this is theta. This is A, this is B, this is C. Okay. Let's start with the Pythagorean theorem, which is A squared plus B squared equals C squared, correct? I'm going to convert this to, or I'm not going to convert, but I'm going to divide everything by C squared. And I'm going to get A squared over C squared plus B squared over C squared equals 1. Do you see how I got that? This right here would be the same thing as A over C squared plus B over C squared plus 1. Or sorry, not plus 1, equals 1, correct? What is A over C? What trig function is that? What is it?
Sine.
Sine. So that's sine squared theta. What's B over C?
Cosine.
Cosine squared theta equals 1. Jeremiah, this is the most important trig identity you will learn in your whole life. Everything deals with this. And I just showed you how to get it, but I would just memorize this. The reason this is so good is because there's also so many applications. Like you can change this, right? Like you can do sine squared theta equals 1 minus cosine squared theta, right? Just by moving that. You could divide everything here. This is a cool one. This is actually one you'll use more often. You could divide everything here by sine squared theta, right? To get, well, what is this? This is 1 plus what's cosine over sine squared?
Cosine over sine.
Cotangent.
Oh, yeah.
Actually, oh wait, sorry, it's cotangent. So when you write squares, you write the square after the sine and not the theta. So you write like sine squared theta, cotangent squared theta. And what's 1 over sine? That's cosine squared theta. So do you see how this is exactly the same as this first one, but you just changed it? Like it looks different. Do you see that? Okay. So again, the most important one is sine squared theta plus cosine squared theta equals 1, because from there you can do everything. And you almost always want to be working with sine and cosine. Okay, did you understand that one? Does that make sense? Okay, good. So let's say, I'm just going to give an example just to make sure you're following me. Let's say I have no, it's not tangent. Tangent squared theta plus 1 equals secant squared theta. How am I going to prove this, right? Because remember, we're proving it. I would personally convert everything to sine and cosine. So I see this as sine squared theta over cosine squared theta, right? That's tangent, plus 1 equals 1 over cosine squared theta. Do you agree with me? I can get rid of all this denominators by multiplying everything by cosine, right? So I get what? Sine
squared theta plus cosine squared theta equals 1.
Sorry. Right? You get to something like this. And then we know that this is 1. So 1 equals 1. Do you see that? A lot of times you'll end up coming back to something like this. Okay, makes sense? Perfect. If that makes sense, do you want to do another example of something like this or no? Do you want to do another example like the one I just put on the screen? No? Okay, go ahead. Remember my tips? Make everything sine and cosine. It's going to help you. Start from the more complicated side, right? Like you want to focus on one side. You want to change one side into the other side. I'd usually go for the harder one, because the harder one is usually the one that you can simplify. Because when you go from something simple, it's harder to go more complicated. And this is just going to require a lot of trial and error, Jeremiah. Like if you get stuck, try doing something different. But you seem to know what you're doing. Let me know when you finish 9A. We'll check it. Krish, you're watching this later. Go ahead, do the start doing the homework 29A. And then I'll put the answers up here as Jeremiah and I check them. Wait. Okay. Lesson 9. Woohoo. Like a third of the way through the book. How exciting.
Already? What?
Yep. We've actually been in this book for a while, but it's been good. I like this book the best, honestly. This is the hardest one they have. It pushes you guys, because you guys usually think everything is easy, but now it's hard. You guys get a challenge. Let me know if you need any help, Jeremiah.
I need help.
With which one?
The first one.
Okay. What I told you it's gonna be a little bit tougher, so don't worry about it. Um, what is your game plan? Remember what I said.
Right. So I changed cotangent to cosine over sine. And then after that I did so to take out the sine theta out of the denominator, I multiplied it all by sine of theta. And so that's what I'm saying.
Okay. If I'm being honest, so I'm gonna look at this again. So you did this. Give me 1 second. Okay. So you started, did you change everything to, you said you changed everything to sine cosine?
On the cotangent side, yeah. But on the
Okay, let's start with the cotangent side. So I'm just gonna work on that side for now. For this one, I would personally change both sides a little bit. But let's start with how far you got. Did you get something like this? Okay, what's your next plan after this?
I would multiply everything by sine to take out the denominator.
Okay, I like that. Right? Because you want to, so the two tricks I have for you, simplify fractions, get rid of, or make everything sine and cosine. So this should become what?
So that would be cosine plus sine, and then cosine minus sine.
Okay, let me give you a hint. This one just might not be as obvious. I would multiply by the conjugate. And that's just me personally because I see this cosine minus sine. And you'll see why, I think. Maybe. Actually, maybe don't do that. Maybe don't do that. I would just keep it like this. Just keep it like this. Sorry. That's if I wanted to simplify it more, but you're just proving. So I'd stop right here, Jeremiah. Do the other side, and you're probably gonna get something similar to this. Do the tangent side.
Proved. That's insane.
It works, right? It's crazy how that works. So do you kind of feel like you know it better now?
Yeah.
Okay, then try the next part.
Sine times cosine zero. I mean one.
Sine times cosine? No, that's just sine cosine.
Okay, I need help with 2 as well.
You need help with number 2. Um, what is your strategy? Which side did you work on?
I worked on the secant plus tangent side
Okay, good,
first.
good. Did you FOIL that out?
Oh, I forgot to do that.
Yeah, I'd FOIL that.
Okay, so I folded it out and then I put it in like
Okay, so you got secant squared minus tangent squared theta.
yeah.
Okay, work on that. Did you get it, Jeremiah?
Got to that part and then I got stuck.
Okay, so what are you at right now?
So I'm at so secant turned into 1 over cosine squared. Secant
Secant.
squared.
Wait, so you have like secant, so you have this, right? Right?
Yeah.
This is 1 over cosine squared, correct? And this is, oh, sorry, not minus, this is sine over cosine squared, right? Do you see something you can do?
So you can like multiply by cosine squared.
Yes. And so you get 1 minus sine squared, correct? Oh, sorry. Sorry, you can't just get rid of the cosine squared. Sorry. Or did you multiply both sides by cosine squared? Okay, because you know the right side is just 1, right? Because it's sine squared plus cosine squared. But then it becomes cosine squared when you multiply.
Oh,
Like at this step right here, it's 1. Right. Did you get number 2, Jeremiah?
I mean, I got it to get proof, but I don't know if I did it the right way because you said like so it
Like
becomes
so did you get to this step right here or no?
yeah, I got to that step.
Okay. Well, then you can just add the sign.
Oh,
Then it's 1 equals 1,
okay. Yeah.
right? Because that's cosine. So that's a weird. These are kind of hard questions actually. Um, I think they're purposely making it hard. Like so, number three and number 4, those are more realistic. That's probably what you're gonna get most of the time. So try number 3. I wouldn't touch the right side at all. Just do the left side.
Wait, so wouldn't it just be like 1 minus sine squared of theta equals cosine squared of theta? Okay.
Yeah, so you get 1 minus sine squared theta, right?
Yeah.
And by now you should be able to recognize that's cosine theta. So cosine theta equals cosine theta, yes. Okay, try the next one. This one is also going to be pretty easy. It's going to be pretty straightforward.
So negative tan squared would just be tan and secant squared. Wait, so it would just be one then, right?
For where?
For number 4 when it has negative tangent squared plus secant squared.
That's also just one.
Okay.
So you basically get 1 plus 1. Do you see it? And then 1 plus 1 is just 2. So how's it going, Jeremiah? You're doing 5. This one's a tough one.
But yeah, I need 1.5.
Okay. Where are you at?
Okay, so first I started with making everything cosine and sine on the left side. So
Okay.
it becomes
Are you okay if I erase some of this?
yeah.
Okay.
So cotangent equals cosine over sine, and 1 minus cosecant is secant, which is 1 over cosine, and then tangent is sine over cosine. So I first want to get rid of the 1 over cosine, so I multiplied everything by cosine. So that makes it like cosine squared over sine over 1 plus sine.
Okay, wait. You're going really fast. Wait. So you got something like this. Sorry, I was trying to write it.
Yeah,
Okay. Then you said you want to simplify this.
yeah.
Okay, good call. What did you get?
Um, cosine over sine.
No. This?
Okay.
Because if I made this sine over sine,
Oh, okay.
right? You can't forget that minus one.
Yeah.
Okay, now that you're here, what do you do?
Cosine. Oh wait, sine theta minus 1 would be.
Let me give you a hint. Look at what the other side. Look at the other side. You're looking at the right side.
Yeah.
Look at the denominator.
Oh,
What did it seem like they're doing? They're just doing like they're doing the common denominator. So you multiply this one by cosine over cosine. You multiply this one by sine theta one or sine theta minus one, sine theta minus one. Do you see that?
yeah.
Okay. Let me know what you get when you do that.
So I got cosine plus sine minus 1 over cosine cosine theta times sine theta minus 1.
Wait. So what'd you get on the top?
Cosine theta plus sine theta sine squared minus 1. Cosine squared plus sine squared minus 1.
Which is what?
So cosine plus sine equals 1.
So it's one minus sine theta, right? Wait, did you say this gets distributed to both, right? So you can say
Yeah.
cosine squared, sine squared, minus sine squared, or sine theta. I guess it gets distributed to the negative one.
Oh, okay. So that would just be sine, which is 1 minus sine.
So do you see that matches the other side, right?
Yeah.
Okay. Do you see how hard it can be, Jeremiah? Okay, we're gonna keep going. If we at least want to finish the other side, Krish, if you're watching this, hopefully you're doing fine. And we're Jeremiah and I have been walking through a couple of them. Here's the homework. We're gonna do 9A. So let's try and finish this, Jeremiah. And the rest of the homework is 9C. Okay. And try your best. It's gonna be hard. But okay, keep going, Jeremiah. Let's do the backside. You got it, Jeremiah?
I got 6, but now I'm working on 7.
Okay, good. Yeah, let's try and finish 7, 8, and 9, Jeremiah, at least. Because I think you can do 10 pretty easily.
Sine times cosine is tangent, right?
No. You said sine times cosine?
Yeah.
No. That's just sine cosine.
I'm stuck on 7.
You're stuck on 7.
Yeah.
Okay. So what have you gotten to?
Okay, so I did the left side first. So tan squared becomes sine over cosine squared, and then 1 minus cosine equals sine squared. And so I did,
Okay, yeah, that's good.
then I multiplied by sine squared to get rid of that denominator.
Wait, you have something like this, right?
Yeah. Yep.
Okay. That's just 1 over cosine, right? 1 over cosine squared. Because the sine squareds cancel out.
Oh yeah, because we divide them.
Okay. Now, once you're there, do you see what to do from here, Jeremiah?
So
There's
then you just
because this is secant squared theta. You could, because I know the answer is a little like if I was gonna do it from your way, I'd work on the other side. You have something like this, right? Oh, sine squared over cosine squared, right? I'd make these both cosine squared, like common denominator. So you get something like this, right? The top becomes 1. So you have 1 over cosine squared, which is secant squared on both sides. So that's how you do number 7.
okay, so for number 8, so I started out with making the left side all sine and cosine. So it would be cosine of theta minus sine over cosine times 1 over sine. So the sines would cross out and you multiply, and then it would just be like cosine
Wait,
minus
the sine. Okay, wait. The signs for the tangent and the cosecant would cancel out.
yeah,
So you have what? Cosine theta minus
minus 1
one
over
over
cosine.
Yeah.
And then that all over sine of theta, and then I did that is equal to negative tan, so that's negative sine over cosine. And then I multiplied both sides by sine over sine to get rid of the sign on the bottom. And then that would just make it cosine minus secant equals negative sine squared over cosine, and then that's where I'm stuck.
Wait, what did you do from here?
From there, I multiplied it by sine to get rid of the denominator.
So this side becomes cosine tangent minus, or cosine theta minus, minus 1 over cosine theta equals negative tan theta sine theta.
Yeah.
Okay, then what'd you do from here?
That's where I'm stuck.
Well, I would combine these two if you want. This is what? Cosine squared theta minus 1 over cosine theta.
Yeah. So then those two would cancel out.
Wait, I wouldn't do that. What's this top?
Sine theta.
Negative sine theta squared. Sorry. Yeah, negative sine squared theta over cosine theta, right? And what is that? That is negative tan.
Negative tan.
And then there's a leftover sign, right?
Yeah. Okay.
So you finished 8, right? Let's do 9 really quick, and then we're going to end the lesson. What are you looking at and thinking when you see it?
So I'm thinking do the left side first. So it'd be 1 plus sine over cosine squared theta plus 1 over cosine squared theta. And then that's all over 1 over sine squared.
Okay. Okay. Then what are you going to do to get rid of these crazy fractions?
Wouldn't like the sign from the top and the sign from the bottom cancel out?
No, because of the plus signs. You had to combine, you have to combine all these first.
Oh, okay.
I would combine it by doing, what is that? That's cosine squared theta plus sine squared theta plus 1 all over cosine squared theta. Do you see that? Because this becomes cosine over cosine squared. Then I just added the tops, put it all, and then that's all over 1 over sine theta. Do you see that? Or sine squared theta? Once you have this, these two add up to 1. So 1 plus 1. So you have 2 over cosine squared theta. And this sine squared theta ends up on the top. And then that is what? 2 tangent squared theta is what you have. Does that make sense? Okay. Jeremiah, your homework is 9C, okay? Okay. I'll also send you this recording, but you did great. Hopefully you understood that. I'll see you next week, okay, Jeremiah? Okay, bye.